we talk about the properties of matter, we've talked about intensive and extensive properties. We want to talk about physical and chemical changes as well. Physical properties, in this case, so I can talk about physical properties and chemical properties. These are observations we can make about the substance during or mixture during a specific state. So generally, physical properties are what you can observe kind of at rest, right? And chemical properties happen while things are sort of in change, in a chemical flux. Physical properties, easy to think about, right? Examples of physical properties that we've got are melting point, color, right? The color of a material, okay? The density of a material, the smell of a material, okay? All of these things are physical properties. So if I open a bottle of pyridine, I'll be able to smell that and say, oh yeah, that's pyridine all right. It's got a very distinctive odor, okay? Chemical properties are properties that happen during during change, okay? Generally as you go from one substance to another, okay? All right, as far as examples go of chemical changes, or as chemical properties, let's look and see if we can think of a couple. We know that iron reacts with oxygen in the atmosphere in the presence of some sort of salt and water to go through a change to become iron oxide. Okay? So chemical properties of iron, or chemical properties example is when iron rusts. You don't have to worry about iron rusting in space because there's no oxygen in space. So you're taking one of those things away. You won't be able to get a chemical change in that case. All right. Another example, okay, is when you put Alka-Seltzer tablets into water. Have you ever seen that pop, pop, fizz, fizz type of commercial? Whenever you put Alka-Seltzer into water, what you're going to be doing is you're liberating carbon dioxide from the effervescent material. That kind of mixes in the medicine that's there. Helps activate it, okay? That's the chemical properties that you can see with Alka-Seltzer. Okay, if you've ever done any sort of baking, when bread rises, the reason bread rises is that you have yeast, and that yeast is generally feasting on some sort of sugar that you prepped it with. And as that yeast eats the sugar, what it does is it breaks it down into carbon dioxide, because it's using that sugar to help metabolize, make more yeast, for example, and also blow off carbon dioxide, which will allow the bread to rise. All that flour is going to become more fluffy because carbon dioxide is filling it with tiny little pockets of carbon dioxide. Have you ever looked at bread? You ever take bread and just hold it up to your face and look at the bread? You'll be able to see little tiny pockets of almost look like cells inside the bread. And those cells that were there are where carbon dioxide used to be. Okay? It doesn't taste like anything. Carbon dioxide doesn't really have a taste. Okay? But bread rises because of the release of carbon dioxide. So these are examples. And when we talk about physical changes and chemical changes, chemical properties you see during these things, for example, a chemical property is when iron rusts with oxygen present. Okay? So that's a property. The change is the process of the iron rusting. Okay, so these two are very closely related. So chemical properties and chemical changes are very closely related. Okay? For physical properties, the changes, or physical changes, for example, there's no change in what the actual substance is. So changes here, chemical properties, you go from one substance to another. That's the change. Here, there's no change in substance. So because you have no change in substance, the material stays the same. For example, when you go from ice and that melts going to water, that is a physical change. And that physical change just indicates that something's gone from one state of matter to another, but it hasn't gone through any real physical change. Or, excuse me, chemical change. It's gone through a physical change, but not a physical. It's gone through a physical change, not a chemical change. Okay? It stays the same. So if something stays the same during its change, it's a physical change. If something changes to something else, it's going to be a chemical change.